All right, so this is part 2 of integration using partial fractions, the partial fraction method. So what we did is we had these 3 questions on video number 1, lesson number 1, and we just went over the answers here for these, and I'll just show those up there again. So question number 1, here's the answer down here, okay, for the decomposition there into partial fractions. That's for question number 1 right there. Okay, there's your answer. For number 2, okay, number 2 is right here. There's number 2. There should be the answer for number 2. Okay, so again, that's this question right here, and that answer. So what we're going to do today is, and I'll show you number 3, but we're going to continue on, because that's the first part. So the second part would be the integration. So here's number 3. Oops, let me zoom in there for you. There's the answer to number 3, question number 3. Just splitting them up into partial fractions. So what we're going to do now is we're going to continue on and we're going to integrate. Okay? So how do we do that? Well, if you take a look at this, when we split this up into partial fractions, we said that the answer was negative 3 over 7 times 2x plus 1 plus 12 over 7x plus 4. So if we get this far, what that means is this: the integral that's represented here can be expressed as 2 integrals added together, like this. And these ones are actually going to be considerably less difficult to integrate. So let's take a look at that. So the first one here, if we integrate this, we can see that we do have a constant. That's the whole point, right? A was negative 3 over 7. And B was 12 over 7. So we'll take those out. Let's take those out. So negative 3 over 7. And then we can just focus on this integral, 1 over 2x plus 1. And we can take this 12 over 7 out and focus on this integral, 1 over x plus 4. All right. Now, if we do that, we take those numbers out. You see that you have 1 over u, right? And when we take the integral of 1 over u, that's ln of u, absolute value of u, right? So we're dealing with logarithms. In the case of the first logarithm here, what we have to remember is that we do have the inner function here, u would be 2x plus 1, and so we do have a 2. When we differentiate, chain rule says we multiply the derivative by 2. So in integrating, we have to account for this multiplication of 2 by undoing that by dividing by 2, really. So as you recall, this shouldn't be anything new, but we have to do this. We have to times 1 over 2 here when we take the integral of this. So that's ln of, and we'll show the absolute value there to be proper, 2x plus 1. So remember, if we take the derivative of this right here, that's 1 over 2x plus 1 times the derivative of the inside function, which is times 2. So we have to account for that. All right, so is everybody clear on that? Integrating that one? Okay. And so, yeah, so then it becomes really easy over here, too. We have 12 over 7 times, now what's this? The integral of 1 over x plus 4. Because this is just a 1, we simply do ln of absolute value of x plus 4. And then plus. Now, again, we're integrating. This is indefinite integrals, so we need to add a constant here. Now, we have to be careful. In this section, you can use c as a constant like we always have. However, we do have constants now from the partial fraction method that may include c. So you'll see that oftentimes this constant is now a k. Okay? So you might see that in some of the problems that you have. And I'll try and use k here when I can. So again, that's just the constant that we don't know about upon integration here.
So k and c are...
Yeah, k and c would be similar. Okay, so we have been doing plus c in the course up to this point. But because we're using coefficients of capital A, capital B, capital C, capital D, we don't want to be confusing there. So this is just plus a constant, okay? All right, so that's how you finish question number 1, okay? So what happens if we have to integrate this one here as number 2? So let's take a look at that. I'm going to erase this for us now. And we're going to find the integral of this one. Of course, the first step would be to split this into partial fractions, which we have already done in the previous assignment. So for number 2, okay, so number 2 we have, let me just get to my notes here. We have 5 over x plus 1. Is this looking familiar to you? Minus 15 over x plus 1 squared plus 22 over x plus 1 cubed minus 21 over x plus 1 to the 4th. So once we've split those into partial fractions, we can then integrate, right, all of these. Take the sum, difference, whatever, of all of these and integrate them separately. So that will get us this far. And we can take the 5 out, right, and integrate 1 over x plus 1 and so on. Take the 15 out, just like we did before. Okay, so once we have this broken down here, we can take a look at each of these. So if we have 1 over u, right, to the power of 1, that's going to be 1 of x plus 1. And because there's no coefficient other than 1 in front of x, we don't have to undo any chain rules, so that's your integral, first one. Now, when it comes to having a squared, right, we can use the power rule, and you can view this, if you want, as x plus 1 to the negative 2, right, if you want to do that. So then we add 1 to the exponent, then we divide by that, and so on, so just kind of undoing the power there. And so what ends up happening there is we get minus 15 times, so what's that? An x, you add 1, you get to negative 1, so you divide by negative 1, and you end up having x plus 1 to the negative 1, or just an x plus 1 down here, 1 over negative 1 times x plus 1. Yes? Okay, the third one here, very similar. We'll get some more practice here. So this is going to be x plus 1 to the negative 3. We add 1, that's going to be negative 2. So that's actually going to be 1 over negative 2 times x plus 1 squared. That's what that's going to end up being. So why don't you do the last one on your own, see if you can get that pattern. Okay. Okay, so just in case you're still wondering here, watch this. I did this. So for the last one, I'm viewing it like this. I'm going to add 1 here, which is going to get to negative 3. I'm going to multiply by 1 over negative 3. And then this is going to be equal to 1 over negative 3 times x plus 4 to the negative 3, which is going to give me this negative 3. I'm going to bring this down here. So what's going to happen is this is going to be 21 times, it's going to be 1 over negative 3 times x plus 4 cubed. Hopefully you can see that on the screen there. It's a bit tight there, but so let's finish this off by simplifying. So this is a negative 15 over a negative 1, so that's plus 15 over x plus 1. This is going to be a positive 22 divided by negative 2, or minus 11 over x plus 1 squared. And then this is going to be plus, because we have a negative and a negative. What's 21 over 3? That's 7 x plus 4 cubed. Plus, okay. Sorry? Oh, what? Oh, whoops. Yeah, sorry. That should be a 1. Yep. Yeah, I don't know where that 4 came from, sorry. All right. Okay, so why don't you guys do 3 on your own then? So 3 here. So you've already split it into partial fractions. go ahead and finish that off by integrating. Let's see what you get. Okay, so based on our decomposition there of this rational, partial fractions, we have, from our answer before, negative 1 over 4x minus 1 over 2x squared plus 1 over 4 x minus 2, right? So if we take the integral of each one of those partial fractions, it should start to look like this. So you should have here that negative 1 over 4 could come out as a constant. Then you just have 1 over x left. So that's a negative 1/4 ln of x. That's your first one. Next one, you can take that half out, I guess, and you just have x to the negative 2 left over. Okay, and so when you simplify that, you should just have 1 over 2x. Here you have a 1/4 times 1 over x minus 2, right? So that's a 1/4 ln of absolute value of x minus 2, and then plus k.
Why is it negative 1 over 2x?
That should be a positive.
Thank you.
Yeah, that should be a positive. Yeah, because this is a negative 2, so it goes up to negative 1, which divides by negative 1, so negative and a negative should be positive, right? Okay? Good on that?
Yeah. So,
Question?
can we still use C instead of K?